you. So today we're going to start these solving problems using systems. So here's my dilemma. So I'm going to tell you my dilemma and my fear, and then you can understand where I'm coming from. So I think that the best way for you guys to learn how to do this is for me to do something. So for me to do some examples and show you, because I know you need examples of how to solve these. And so I want to do that. And then I think a really good way to do it is for you to really try to stretch yourself and try to do some problems and try to get the answers while I'm here and Mrs. Navickas is here. We can help you so that you don't get home at night and there's no one to help you and you're lost, and next thing you know, you come in the next day, I couldn't do it because I just don't know where to start. My fear is this, so I'll share my fear with you. So that I think that will help you. My fear is that if I do some examples and I stop talking about 15 minutes and say start the homework, do the problems, and I will come around to help when you need it, my fear is that in a class of 19 of you, 9 or 10 of you will shut your books and think, well, class is over, and so now I'm going to do a million other things. And so that it sort of defeats the purpose, because I can sit up here and keep talking if that's what I wanted to do. But I really want to help you to solve some of these. And a lot of times, if I'm just doing it on the board and I'm solving it, you can follow along. But when you actually do it yourself, you have a hard time. So to learn how to do these, you really have to spend some time doing the problems. So I'm going to try that today. So if you can please be sensitive to that and not just close your book. I mean, I understand 2 minutes before, pack up. I know you don't want to rush out. You only got 3 minutes to go. But with 5 or 10 minutes left, please don't shut the book and talk to your neighbor. Really try to get into this homework, and I want to come around and help you where you need it. Okay. We're going to solve problems. So I've written the problems here, and I'm going to go through and do some of these for you. Carrie asked a bank teller to cash a $390 check using $20 bills and $50 bills. If the teller gave her a total of 15 bills, how many of each type of bill did she receive? All right. So these are the kind of problems. Now, keep in mind, when you're doing these, always when you're doing the word problems, think to yourself, what section am I in? Like, what is it that they're sort of trying to get me to do? So when you're setting these up, realize, what have we been studying? How to solve systems of equations in 2 variables. So you're going to have 2 variables, and you're going to have 2 different equations on these problems, for the most part, because that's the section that you're in. This is just turning your words into those equations. So I'll start with Carrie.
What page are you on?
Section number is 3.6, which starts in 131. Page 131. And actually, I copied this right out of your problem. This is number 1 in your problem section. On page 132, this is problem number 1. Your homework, by the way, is the odds. So, and I'll just quickly, because some of you don't want to look it up online and have the sheets, I can tell you that it's going to be 2 through 14 even, and then 32 to 40 even. So 2 to 14, 2 to 14 even, and what did I say? What was the end of it? I said 32 to 40 even. So that's 8, and that's 12, there's 6 and 4. That's only 10 problems. I know that sounds like a lot, but it's 10 problems, and I know they're a little harder because they're word problems. Okay, so I have Carrie. So a good way to start these is realize I'm going to have 2 variables. We're talking about Carrie. So I'll use a K. You can use any variable you want, but I'll use a K to represent Carrie. And she asked a bank teller. Oh, I don't. Carrie's not important in this problem. Good thing if I read it first, right? Her name really isn't important. She's not the variable. She's just somebody who asked a bank teller to cash a $390 check. So she has $390. That's what her check is worth. $390. That's what she has, is a check. Okay. And so she wants to cash it, and she wants to get her $390 back, and so it's going to equal something, and she wants $20 bills and $50 bills. Okay. So you got to pick 2 variables to figure out how much money she has. So for the $20 bills, maybe, if you want to use X and Y, you can. If you want to say a T for 20, sorry, 2. If I want to write a T for 20, those are $20 bills, okay? And $5 bills. And I can use an F for that. Okay? So if I'm going to use $50 bill, or sorry, $50 bills and $20 bills together, she has how many types of bills? Here. 15, sorry. She has 15 total bills. So my number of 20s and my number of 5s, I have 15 of them. Total of 15 bills. Okay. Now, I don't know how many $20 bills I have. I don't know how many 20s I have, but I do know how much they're worth. How much is a $20 bill worth? $20. So $20 times the number of $20 bills I have will give me my total value in 20s. And then I know that I have, for $50 bills, I have however many $50 bills I have, multiplied by 50, because they're worth 50. And then that was a total of $390. Okay? And so now what do you have? You just have two different equations and two variables that you can solve, a system of equations. So once you get to this point, it's just solving some equations. So I can erase the words. And I guess we kind of like the variables on this side. So I'm just going to put t plus f equals 15. I'm just rewriting them. I'm not doing anything different except for putting them on this side of the equal sign. And what am I going to do here, Maggie? How am I going to solve it? I'm sorry?
Like, you don't reduce, can you reduce by 10?
You reduce these by 10?
Yeah, like,
You could. If you want to call that t, 2, yeah, 2t. I should put the variables second, but I guess it doesn't really matter. 5f equals 39. You could do that. I don't know that you need to, but you can. That's fine. Now what? You want to eliminate one of the variables, right? So you need either one of these to be opposites of each other. So you need a positive and a negative at the same value. So which would be the easiest equation to transform?
oh, the top and the, okay.
Top one. And so I need it to be a negative 5f. So what will I multiply that whole equation by?
Negative 5.
And what will I get left?
I got what you're doing now.
This is kind of weird that I have that out in front. It's a lot easier for you to do it if I put it behind. It's the same thing either way, but what do I have left? Distributing.
Oh, yeah.
What do you have to tell me what it is?
Oh,
Negative 5 times t.
Negative 5t.
Negative 5t.
Plus, or subtract, yeah, minus 5f.
Equals 15 times 5. Who can help her? 15 times 5.
75.
Negative 75. Right? Okay. And so now I can start eliminating. Notice that I have the plus 5f and the minus 5f. So I just have t minus 5t, or minus 3t, equals, what do I have here? What's negative 75 plus 39? I'm sorry? 36, right? Negative 36? Okay. And then if I divide both sides by negative 3, what am I left with? T equals 12. So what is my T? You got to go back to your problem here. My T is my $20 bills. So I have 12 $20 bills. So how many $50 bills do I have? Because I want to know each type.
3.
And it's 3. Yeah. Good. And notice that if I have 3 $50 bills, that's $150. And if I have 12 $20 bills, that's $240. And 240 and 150 is $390. Okay? So setting up a couple equations and two variables, and then solving. All right. This is everyone's favorite when we get the geometry comes back, right? Find the measure of the angles of an isosceles triangle. So that's my isosceles triangle. I'm sorry? If the measure of the vertex angle is 40 degrees less than the sum of the measures of the base angles. All right, so these are my base angles here, right? You remember this from geometry. Right? And what is my vertex angle? I'm sorry? 40 minus the sum of the measures of the base angles. What's the sum of the measures of the base angles? I'm sorry? What's the sum of the measure of the base angles? 2x. And it's, I don't have enough room to write there, so. And it was 40 degrees less than 2x, right? Is it 40 degrees less? Okay. So how am I going to set up my equation? This one, I guess it only gives me one variable, which is weird. Okay. How am I going to set this up, Jared? What do I know about the angles in a triangle? The angles of a triangle add up to how many degrees, Jared? All right, anybody? Who? 180. Okay. Yes, geometry's coming back. So all of those together equal 180. So that would be 2x minus 40 plus x plus x. And then you could simplify that. 40, yes. Not copying it. Okay. And so 180, how many x's do I got there?
4.
X minus 40. And then it's a simple equation. Add 40, 220 equals 4x. And what's x? 55. And the question asks me, find the measures of the angles in an isosceles triangle. So it wants all of the measures. So what's this angle? What's this angle here?
55.
And that's the same, obviously. And then what was this one?
60.
Because 55 times 2 is 110. 110 minus 40 is what? 70. That was it for that. Now let's do another one here. On Friday, the With It clothiers sold some jeans at $25 a pair and some shirts at $18 each. Receipts for the day totaled $441. On Saturday, the store priced both items at $20, sold exactly the same number of each item, and had receipts of $420. How many pairs of jeans and how many shirts were sold each day? Okay, so some of you look at that and they think, where in the world do I start? So let's see. You have some jeans at $25 a pair. So a good place to start would be 25J, because you have the value of the jeans are the number of pairs times $25 a pair. And you have some shirts at $18 each. Okay? So my shirts were sold, however many shirts I have, I would multiply by $18 the price, and then that total would give me the total amount of money that I think were sold for. And it tells you right there that it was sold for $441. So that is how you set up the first equation. Now we know there's going to be a second equation. On Saturday, the store priced both items at $20, sold exactly the same number of each item, and had receipts of $420. Well, and I'm just going to put a little Friday over here so we remember what we're talking about. And then this is Saturday. And how much money was made on Saturday? $420. And it says both were priced at $20. So $20 jeans plus $20 shirts. And so how would we solve this equation? So that's all I need for my writing so I can scroll up. Now I got two sets of equations and there's two variables. So what would I want to do first, Bethany, on this? I freak some of you out because I know your names and where you're sitting, and so I'm looking at one person and I call someone else's name, and they're like, what do I have to do whenever I have two equations with two different variables? I have to eliminate, right, I have to eliminate one. Which one do you want to eliminate? You want to eliminate J. That's fine. One thing I can do, you can do this the exact same way we've done all these problems with those big numbers. But just notice when you have common numbers, it may be easier for you to do what Maggie did on the two problems ago and reduce some of these. Because you can, when you have an equation, you can divide anything by either side as long as you divide both. You may decide that dividing 20 here may make the problem a little easier for you than working with such large numbers. You can still get the same answer either way, but you could rewrite that equation as J plus S equals 420. So 5 times 4 is 21. Okay. So if I have that, and then I have 25J plus 18S equals 441, that may be a little bit easier for you to work with, Bethany. So how am I going to transform these equations so that one of those will eliminate? You want to eliminate the J. That's what you said. So what am I going to multiply? If I want to eliminate this J, then I have to turn this into negative 25J. What am I going to multiply that equation by to get a negative 25J? Negative 25. And that will get me what? What will I be left with? I'm sorry? You already multiplied 500? No, it'll be more than 500 because you got 441 times negative 25.
No, it's 21.
Dude, what in the world?
Not the 440. You're multiplying by the first equation, not the second.
Oh, well, I got you. The first equation. And you already did that in your head. So 25 times 20, that'd be 525, yes, because of it's negative, right? Negative 525. Okay. So now, Bethany, what am I going to be left with? Notice that you did get these nice and eliminated. And what am I going to be left with? Negative 7S. Negative 84. What's that? 525 minus 441 is 59, 69, 79, negative 84. Are those the right numbers? Came out to a fraction. S equals what? 12, right? Okay, so what does all that tell us? So we know S is 12. Now you got to go back up into your original equations. So if S is 12, find our shorter equations. All right. If S is 12, what was J that equaled 21? If S is 12, what was J? 12 plus what gives you 21? 9. 9 plus 12 is 21. So how many pairs of jeans and how many shirts were sold each day? Well, 9 jeans and 12 shirts. Does anybody have any questions on that? Okay. You have exactly 15 minutes. So start your homework. You have only got 10 problems. You could probably get a good chunk of that finished. I will come around to help you.